Okay, so we've loaded in the data, looping through using load one, and then we actually did quite a bit in the second one. But we removed, detrended the data, calculated the annual maximum, did a Gumbel fit, checked that fit using this simple parametric model, and then we plotted the return periods, compared them with a GEV fit. Okay, what I want to do is a final step now, which is actually to raise the return periods by sea level and see how much they reduce. So if you raise return periods by half a meter, will a 1 in 100 become a 1 year event, for example? So I've set up control 3. I can borrow all of this. I'm going to load in the data. Obviously, this M file assesses how return periods change with sea level rise. Okay, and first thing we're going to do is actually load in a sea level. Let's be careful and be technically fine. A mean sea level projection. Okay, so what we're going to do is we are actually going to go onto the UKCP 18 user interface. UCP 18 user interface. This is UK climate projections run by the Met Office. Now you'll need to log in first. Up in this corner, I've already logged in, and you'll need to register probably. But we're going to go to this and we're going to tick marine projections, and we'll just pick scenario 8.5. Okay, and we're going to go to this top one, these sea level anomalies from 2007 to 2100. Okay, so let's click that. So we're going to do the mean projections. We're going to do a time mean sea level anomaly. That's the baseline period, so it's kind of 1990 an average. We're going to pick a high scenario, and then we're going to zoom in here, and we're going to go down to Portsmouth. So you can click a point anywhere around the country, but we're going to go for Portsmouth. We're going to go right up to 2100, and we're going to save it as a CFSV in this case. So click submit. So your job is being submitted, and it will take a little while to generate the product. So you just have to kind of wait a little bit. I can't remember how long this took the first time I did it, so let's just be patient. Jobs completed. Okay, and it should reload the page. Okay, and then we can download. So we can go back to our download page, and let's copy this into I'll delete that. Remember, it saved it in the wrong place last time. Okay, let's copy this into our projection folder. And it's this CSV file we want here. Now let's give this a more meaningful name. So let's call it mean sea level. Let's call it RCP 85 and PTM for Portsmouth. And I'm just going to cut and paste that name. So I'm going to use that name here. And let's have a look at this data set. So this is a CSV, so you could open it in Excel if you wanted to, or you can open it in. So this is what it looks like. Okay, so you have 13 lines of data, then you have the year, month, day, but it's essentially just the 1st of January. And then you have the 5th percentile, the 10th, the 30th, all the way up to the 95th. Okay, so let's load this in. So let's first of all create a file in square brackets, because we're going to join text together. Well, in fact, in this case, we don't actually need square brackets because I'm just going to load this as a one-off, but it's going to be in the data folder. It's in the projections folder. And then we're going to use the text read function that we used before with file in. Okay, so let's go through the columns again. So there's a year, then there's a month, then there's the day. Then I'm going to put PR for projection. I'm going to have column 1. and there's actually 7 columns of sea level, 9 columns of sea level if I remember right. So that's the 5th percentile, then I think it's the 10th percentile. We can work these out later. But if I remember right, there is 9 columns. Okay, and then, because I put 3 dots, it goes on to the next line. Now we need to tell it the format. Okay, so we have %d for the year, and then I think it's got this symbol, %d, then there's a column, and then it's a floating number. So I've got 3, 4, 5, 6, 7, 8, 9. It has to exactly match. And then header lines is 13. Okay, let's run that. Okay, unrecognized files, because I called it file in, and here I've missed out the E. It's still saying the file's not found. So what have I done wrong? It's not projections, it's projection. Okay, now I've screwed up one of the columns. So let's just go through again. So we have year, month, day, PR 1, 2, 3, 4, 5, 6, 7, 8, 9. And let's just check I've done this right. Year, month, day, 1, 2, 3, 4, 5, 6, 7, 8, 9. So what have I done wrong? Header lines. See, I always do something wrong. Okay, now it's loaded in. Now I don't really need the month or the day because it's always the 1st of January. I don't really need the file in anymore, so let's get rid of that. Okay, so here are my sea level projections, and the year should go from 2007 all the way to 2100. Okay, so let's plot that projection. And again, just to save me time, always do this, just cut and paste and edit. Okay, let's add a X label, which is going to be year. Okay, so I'm not going to plot all of the projections, but let's plot Y. Let's plot column 1, which is the lower projection. I think it's the 5 percentile. Let's plot column 5, which is the 50th percentile, so the kind of lower, middle, and upper. Let's do green, black. Okay, and we probably should put in a legend, so it's the 5th percentile, it's the 50th percentile, and then the 95th percentile. Put a new line and location, and let's put this as northwest. And the title could be Mean Sea Level Projection, RCP 8.5, High Submission Scenario. Okay, so let's run that. So as always, I've made a mistake. It's not recognizing Y. Oh, it's YR, that's why. It's a bit late in the day now. And rather than northwest, let's make that northeast. Okay, it's saying there's 3, 1, 2, 3, 1, 2, 3. It's because I spelled location wrong. It's not northeast, it is northwest I just spelt it wrong. Okay, so that's your projection. So you can see that sea level rise is going to be anywhere between 0.5 and 1.1 meters by 2100. By 2050, it's kind of up to 4. Okay, and this is all relative to 1990. Okay, so what we're going to do now is actually raise the return periods by this amount. But let's extract the mean sea level rise projection for 2100 and offset the return period by this amount. Okay, so what I'm going to say is let's just do it in 2050, not all the way up to 2100. Let's say find YR is equal to 2050. So it's going to find the row number. And then I'm going to say sea level rise, column 1 is the row when it's 2050 and the 5th percentile, which is the first line of the projections. Then I'm going to say, let's put these in as rows, 2, 3. So it's 1, 2, 3. And this is going to be 5. This is going to be 9. So 5th percentile, 95th percentile. So let's run all that. Okay, so sea level rise is 20 centimeters in 2050. Yep. It's going to be that one, which is 29, and then it's going to be 39, the upper one. Okay, brilliant. Okay, so now we can, this was step 4. Okay, now we can plot this. Step 5 is plot. Okay, so again, I'm going to borrow this. I'm going to change this to subplot 2. Make sure you change this. Okay, and what I'm going to do now is go back and remember I've loaded in the return period from previously. So in fact, I think I might have copied this in wrong, but this is what I want to have loaded in the return period. I think I actually loaded in the wrong thing here. It's the return period that I want to load in. So let's just shut that down. Okay, so we have this return period here, which was the GEV fit. Okay, and let's go back here and borrow this line of code here. It's number 2. Okay, so in the subplot, I'm going to fit that. Let's do that as a red line. For some reason, when you have a semi-log, you need that first before the hold on. I've never quite worked out why that is. We're going to copy and paste this 3 different times, and we're going to have blue, green, and black. And what I'm going to do is I'm going to add this sea level rise. So it's going to be exactly the same, but I'm going to add the 20 centimeters, the 29, and the 30. Okay, so let's plot. Let's just run everything now. Okay, so there you can see. And I'm just going to add something. Oh yeah, let's go back and add in this nice X label again. So it just kind of gets the X label looking good. And then what I'm also going to do is plot. And I'm going to go from 1 to 10,000 because that's my limit. And here I'm going to plot let's plot this as a dotted magma line, but here I'm going to plot the return level of the 1 in 1,000. Okay, so the return level of the 1 in 1,000, so it's column 9, row 9, column 2. So let's just run this one again, run advance, and run advance. Okay, so I've plotted the 1 in 1,000. So the 1 in 1,000 today is around 5.8 meters, but you can see that with sea level rise, it becomes a 1 in 10 at the lower end. In the middle range, it becomes a 1 in 3, and then in the upper range, it becomes a 1 in 1. So you can see how as sea levels rise, what today would be in a 1 in 100 year event becomes a 1 in 1 at the upper projection, a 1 in 3, or a 1 in 10. Now, let's just put the legend. So we're going to put today, then it will be with the kind of 5th percentile, 2050, 90th percentile, 2050, 50th, 95th, and then the final one, which is what we're going to call this, the 1 in 1,000, 1,000 or something. Yeah. And let's change the title. So it's B. So it is return period change with mean sea level rise. So if you were to build a flood defence at this site that was protected Portsmouth to a 1 in 1,000 with sea level rise, you'd actually have to build it sort of 40 centimetres higher to still be a 1 in 1,000 by 2050. Does that make sense? I hope that makes sense. Okay, so let's just do one final step now. And we've done that visually, but let's actually work out what it is. Let's quantify the change and work out change in return period. So this is our kind of final step. Okay, so what I'm going to do is say I is find, and I'm going to find the return period in column 1 that's equal to 1,000, so that I can change this. I'll show you. So I'm going to say return period let's call it return period out or something. Let's put this as row 1, column 1. And what I'm going to do now is use the interp1 function, interpolate a kind of one-dimensional function. So I'm going to say it's the return level 2, it's the return period, so it's the second column of RL. Should have RL2, sorry. Yeah. So first of all, I'm going to give it the second column. So I'm going to give it all of the second column, and then I'm going to give it all of the first column. So that's the kind of data. And then I want it to interpret the second column, but just the 1 in 1,000 year value. So this one here. So that's today's one, and it should just give us exactly the same answer, 5.085. In fact, we can check that. This should be 2, sorry. Oh, it's given us, yeah, this one, the X 1,000. So it's exactly 1,000, which is what we need. And then into row 2, we're going to add sea level rise. So sea level rise gets added to this second column, so the first one. So we're going to add the sea level rise. We're going to add each of these 3 sea level rise. So the 5%, 50th, and 95th percent. We're going to put that into column 2. Then we're going to add the middle one. We'll put that into column 3. And then we will add the third column and put that into column 4. So let's run that. Okay, so let's look at the answers. Return period out. So basically what this shows us is a 1 in 1,000 year today becomes a 9.95 years in 2050 with the lower projection. It becomes a 3.7 with the mid projection, and it becomes a 1 in 1 year return. So you can see this is why sea level rise is so important. Even a small, even a small 40 centimeter rise in sea level can change a return period from a 1 in 1,000 to a 1.2. And that's because the return period is quite flat at Portsmouth. Okay, so I hope you've enjoyed these 4 MATLAB tutorials. It's been a real pleasure teaching you. I hope you persist. Now, Ian's will be very slightly different to mine because you're going to use a tool that he's developed. But as always, make sure you update your README. I'm just going to cut and paste, if that's right. For example, I pre-prepared, but keep an eye on this. And remember, if you close everything down, when you open this up again, just open the README file, run this, and it will open up everything for you. And hopefully you can just run any stage super quickly. Now here we've done it for Portsmouth, but in theory we could download the BODC for any site. We could download Dover, have a go at it if you want, download Dover, and you just change this to DOV from the BODC. So again, hopefully you've seen the power that, yes, it's taken us an hour to do this, but now we can run this for any site around the UK coast. Okay, all the best.